You're with Sonia Feldhoff.
Sonia.
On ABC Radio Adelaide, South Australia and Broken Hill.
Now, something very different from roller skating rinks to your own home. You may well want to roller skate in your own home, I don't know. But anyway, we're talking, and it's difficult to talk about this in winter because I guess most of you are feeling pretty cool in your homes at the moment, perhaps. But of course, when summer hits, it can be very, very warm in some people's homes if you're not employing things like air conditioning and other things. We know that we try to build homes in a way that is as cooling as possible. And a new trial is looking at a product that could make cooling your home as simple as slapping on a bit of paint. Dr. Ehsan Sharifi is a senior lecturer in the School of Architecture and Built Environment at the University of Adelaide. Dr. Sharifi, thank you for your time.
Thank you for having me, Sonia.
Now, there is a trial underway on a couple of homes in the Adelaide City Council area. What are they using to see if they can cool their homes?
So it's a new ceramic-based painting that you can put on your metal roof, and it's going to cool down the surface of the roof for you up to, like, say, 20 degrees.
Does it only apply to iron or metal roofs?
No, it can be applied on many things, but particularly on metal roof, it has more significant effects.
Are metal roofs among the hottest kinds of roofs?
That's true. That's true. So basically, the very thin layer of metal that we have in most of the newer even homes, that tends to get significantly hotter than the other surfaces. We are talking about, like, in a day of 24 degrees, you can have a 60-degree metal roof on top of your head.
Wow. Okay. And what does that translate to inside the house?
Inside the house, you're talking about 5 to 7 degrees different in air temperature.
Oh, that's significant, isn't it?
That's significant, especially during the summer when you don't want the hot weather. That's significant, yeah.
Yeah. Okay. We are talking about those hot temperatures. So we're talking about those summer-based temperatures. And when we talk about cooling the house and when it comes to paint or colours, we often have the discussion about light roofs, in particular white roofs. Is it the colour of this paint that's significant or something else?
It's not just the color. Color is a factor. The other factor is how much that coat have the ability to give away the heat. And part of that is the reflection of the roof. And the other part is something that is a jargon, but we call it emissivity, which is exactly what I described before. How able is the paint to give away its heat when there's no sun, basically during the afternoon and midnights. So there are three factors there.
Now, this is a ceramic-based paint, you said, and overseas it has shown some good results. You're testing it to see if it has the same results here in Australia. But what are we seeing overseas in terms of this ceramic paint?
So we are seeing in the United States and in Japan in particular, something around 30 to 32 degrees difference in the surface temperature. On some of the commercial homes, some of the residential homes, some of the commercial buildings. And look, to be honest with you, based on the sun that we have in South Australia and the summertime that we have, I wouldn't expect anything less than that.
But we could perhaps see even more?
We could.
Because what?
Yeah.
Are our temperatures higher than those in the places in which they've been tested in Japan and the US?
Because our sun is more intense than their sun.
Right.
So our sunshine here is more intense. So basically, when we applied the trial codes on those two buildings in the city, and it was winter, basically just before at the start of the winter, when we had a couple of days of warm days, on a day of 24, we actually measured that 30-degree differences. So I would expect much more in summer.
Was this ceramic paint developed for this purpose, or was that found just as a pleasant addition to
No,
the.
it's a good question. It's a very good question. It's actually being developed. This particular product, there are some other products in the market as well, but this particular one has been developed in NASA for their industrial purposes in 1980s, 1990s.
Did you say it was developed by
And
NASA?
yeah, in the
So,
United
so
States.
what,
Yeah.
to be used on their spacecraft?
I'm not quite sure, but probably, yeah. They have research projects which they do not have a particular use for the research in the beginning, and they developed that product. So at the time, it was developed by the support of the NASA for their actual for the uses of in their product that could be their uses in the aircrafts. Could be. I'm not quite sure about
Yeah.
that.
So if this product, this ceramic paint, has been around since the 80s or 90s, I think you said,
That's right.
why are we only just starting to see the benefits now of its cooling properties?
A couple of matters. One of them is that it was expensive at the time. Now it's not more expensive. Like it's not a lot more expensive than the normal paints, but it used to be very expensive. And the other thing that's back in 1980s, 90s, there were not that much discussion about the ceiling being hot and people actually being ill or diseased because of the heat. So nowadays we have more awareness of the climate change, as well as the product itself got to a reasonable price.
You're monitoring, I think, 2 homes in the southern parts of the city of Adelaide to see if it's having similar kinds of impacts on temperatures. Probably you're not going to get your most significant results through winter, but what have you found so far already?
So look, the products have been applied 2 weeks ago, so we are not that far from their application. So we had some data, extensive data, a few months of data from before when they applied, and we are collecting the data still up to the summertime. So a quick test that we did a week after the application showed that the surface temperature was up to the expectations, like around, as I said, around 30 degrees difference we have in the surface temperature. When you translate it into the air temperature, we would expect the same thing that we got in the other countries, around like 5 to 7 degrees, but we haven't got those data yet. So we're gonna wait for the data to emerge, and then we see how we go in that term.
Yeah.
And what we see at the moment is the winter time, as you said. So we're gonna have a different dynamics in summer.
Yeah. So as you've mentioned, look, this is a product in general, ceramic paint, that's been around for some time. Do these cooling properties only, you believe, apply to this one commercial product developed by NASA, or would it be across the ceramic paints?
No, not at all. It's not even the ceramic paints which have this effect. So we have a range of cool paints and cool coating materials with different technologies. Some of them have nanotechnologies these days. Some of them are ceramic technologies. Some of them are even normal paint technologies, the polymer technologies, but they did a bit of change in their properties. So it's not just that particular ceramic technology in the paint. It's as I said, there are 3 parameters in them, and we tweak those 3 parameters, and it gets cooler paints compared to the normal one. They could look like exactly the same as what you see as a normal paint, but a few tweaks in there make them cooler than the actual product. And one of those products are actually being developed here in Australia, in Sydney.
Martin at Crystal Brook says, I painted my roof with a ceramic paint around 16 years ago. It was made here in Adelaide and well worth it. So for some people, this has been known. I guess we're just starting to really try to quantify what impact it might have.
Exactly. And back in time, probably Martin paid a bit more than what we need to pay these days for those coats.
Can you give us an indication? I mean, sort of how much more expensive would this kind of paint be than the average paint?
So I'm just roughly approximating the numbers, but look, if you want to paint your roof these days with a normal paint out of the shelf, you're paying with the application something around $20 per square meter. Here we are talking about $25 per square meter, so it's
Okay.
20%. Yeah, it's not a huge hit, especially if the homes are in that stage that they have to be repainted. So then that's a good viable option on the table.
Okay, so we're not talking about a brand name product specifically. It's a type of paint, and that is ceramic paint. Dr. Sharifi, one texter asks whether this product would work on cement tiles. Can you hypothesise as to whether it would?
It would. I mean, it would stick on almost any surfaces. So these are, as I said, they are coats, they are paints, so that you can paint any surfaces. And in terms of the applying on the cement surfaces, the effect you will get, it really depends on the thickness of the cement surface as well. So imagine that comparing to a roof sheet to, for example, a cement surface, you have a different mass of materials. So that means that your material have a different capacity to store the heat in its own mass, if I make sense. Then its property is going to be slightly different from what you get from the metal sheet. Probably you're going to get less effects on a cement sheet than a metal sheet, but you will still get a significant effect.
Yeah. And I guess finally, a lot of people have talked about the colour of roofs and the fact that many of us are addicted to dark roofs these days. If you used you said you can get a light colour and that would make it better, but could you use ceramic paint and still have a dark colour but have a similar effect?
You can. Those dark, cool roof are still not very economical to apply on your homes. So we have products which are actually they use nanotechnology in the particles of the roof, and they look dark, but they are pretty cool. And we use some of them in the refrigeration industry. They are for large application on the homes. Dark, cool roofs are not still very economical to
Yeah,
apply.
all
But
right.
they are definitely there. If somebody wants to do an exercise, they are there.
Well, I would love to talk with you when you complete the study to see definitely whether it meets the standards that you're expecting it to, and we'd really be keen to chat back with you again.
Likewise.
Thank you for your time. Dr. Ehsan Sharifi, Senior Lecturer in the School of Architecture and Built Environment at the University of Adelaide. That trial underway in the southern part of the Adelaide City Council on 2 homes to quantify what sort of difference that paint makes. And for all of you asking, can we buy it? Well, it's been available for years. Some people have actually used it. It's just becoming much more affordable now. It's a ceramic paint. But just checking on our text line, before the news, we were talking about a paint that could make your house cooler. A lot of you were very pleased to be listening to that and hearing about it. Got a text from Shane at Neotech Coatings. He says, that was a great chat. The product the council is trialling is Supertherm, which blocks 96.1% of solar heat and lasts over 20 years. While there are other products, Supertherm is very unique in its properties and used globally, says Shane. So he obviously knows a little bit more about that. That's certainly the product they're testing there, no doubt about that. So they're trying to find out a little bit more on that front.